Hi, my name is Robin Heft. I'll be talking to you today about how the body uses magnesium to promote bone growth and how we can use that to our advantage in surgery. Before we get into anything too fancy, we first have to understand how bone is formed. Bone cells, or osteocytes, are constantly being recycled. This process is called skeletal metabolism. There are two types of cells responsible for establishing skeletal metabolism. The first type of cell is an osteoblast. They're in charge of building up new bone cells. The second type of cell is an osteoclast, and they're in charge of breaking down old bone cells. The equilibrium between their activities must be closely monitored so no overgrowth or undergrowth occurs. This equilibrium is set through the endocrine system, which is in charge of making hormones. These hormones are synthesized in the kidneys and require magnesium. Magnesium takes inactive, or biologically useless, vitamin D3, we call that cholecalciferol, and it turns it into its biologically active counterpart, calcitriol. Calcitriol is the osteoclast regulatory hormone, so it can increase or decrease osteoclast activity to maintain homeostatic skeletal metabolism. So when there is an increase of magnesium, more vitamin D3 can be activated into calcitriol. When there is an increase in calcitriol, more osteoclast activity occurs, which means more bone is broken down. So how can magnesium promote bone growth if it also increases the amount of bone that's being broken down? Well, according to most researchers, that answer is unclear. There are many studies that are being conducted today to unlock the secret of magnesium. One study from the Brazilian Journal of Medicine and Biological Research says that when there's an influx of magnesium, more unspecialized cells are genetically mapped to become osteoblasts. This process happens through gap junctions, and gap junctions are protein channels that allow for the flow of electrical signals and biomaterial between two adjacent cells. This study showed that when magnesium was introduced into the system, general communication, or gap junction intercellular communication, increased. When gap junction intercellular communication increases, more unspecialized cells have an osteoblast genetic marker implemented, therefore causing more osteoblasts to further develop. More bone-building cells created at a genetic level offers an explanation as to how magnesium promotes bone growth. We can debate why this phenomenon happens all we want, but the most important thing we need to ask is how are we going to use this in the most efficient way possible? Surgeons have already started to use magnesium alloy implants in order to speed up the recovery time of patients. Magnesium has shown us that there's a way where we can naturally enhance our body's healing capabilities on a biological molecular standpoint. If we can master that, then the possibilities of medicine are truly endless.